Hi! In this video, you will learn how to store a whole lot of objects, how to store big data using distributed hash tables. So big data is when you need to store trillions or more objects, for example, trillions of file addresses in Dropbox, or user profiles or emails and user accounts, for example, in Gmail or services like that. And you need fast search and fast access to that data. So hash tables in general is a good solution for that problem because they give constant time search access on average, but for number of keys on the order of 10 to the power of 12, the amount of memory that a simple hash table will store becomes too big to store it on one computer. And so we need to do something else. We need to use more computers probably. And the solution to this is distributed hash tables. So the first idea for a distributed hash table is the following. Just get more computers, get 1,000 computers. If you are Google or Dropbox, you can do that. And then you will store your data on many computers. And you will do the following. You create a hash table on each of those computers. And then you will separate the data between those computers. So each computer will store its own part of the data. And you need to determine quickly and automatically and deterministically which computer should store some object O. And there is a simple way. You just compute some hash function of this object, modulo 1000. So you get basically a value from 0 to 999 for each object. And that will be the number of the computer which should store this object. And then you send request to that computer and search or modify what you need to do with that object in the local hash table of that computer. And that seems to already solve our problem, because if a new request comes, you quickly compute a hash function on the object and you know where to send your request, and then that computer just looks up in its local hash table. Each of the local hash tables can be 1,000 times less than the total amount of data stored, and so it is scalable. If you need more data, you just get more computers and everything works. Still, there are problems with this approach, and the main problem is that computers sometimes break. And especially if you have a lot of computers, then they break pretty often. For example, if a computer breaks once in 2 years on average, then if you have 1,000 computers, on average more than one computer breaks every day, because there are less than 1,000 days in 2 years and you have 1,000 computers. So what do you do in that case? You don't want to lose your user's data, so you need to store several copies of the data. So basically you cannot do it in a way that every computer stores its part of data. Each part of data should be stored on several computers. And what happens then when some computer breaks? Well, luckily the data which is stored on this computer is also stored somewhere else. But if that's the only copy left after this computer broke, you need to also copy that data to some other computer so that it is again stored in several places. And you need to relocate the data from the broken computer. And also, sometimes your service grows and you want to buy more computers, you want to reply faster to your clients, and new computers are added to the cluster. And then this formula take hash value of the object modulo 1000, and this is the number of computer on which your object is stored. It no longer works because the numbers of the computers always change, new computers come in, broken computers come out, and so you need something else. And one way to solve this is called consistent hashing. So first we choose some hash function with some cardinality m, and we choose a circle, a regular circle, and we put numbers from 0 to m-1 on this circle in a clockwise order. And then each object O is mapped to some point on this circle corresponding to the number hash value of this object, which is from 0 to m-1, so it always maps to some of the numbers on the circle. And also each computer ID is mapped to the same circle. We hash the ID of the computer and we get the number of the point to which this computer is mapped. So let's look at the picture. Here's our circle, and for example m is 12, then we put 12 points around this circle and we put numbers from 0 to 11 around this circle. And then objects such as, for example, name Steve can be mapped to some of those 12 points, and if hash value of Steve is 9, then Steve is mapped to the point with number 9. And also computers can be mapped to points, and for example this computer with ID 253, if the hash value of 253 is 5, then this computer is mapped to the point 5. So what do we do then? We make a rule that each object is stored on the so-called closest computer. Closest in terms of the distance along the circle. And in this case, each computer stores all objects falling on some arc, which consists of all objects which are closer to this computer than to any other computer. Let's again look at the picture. This is the circle, and there are 6 computers. And these computers map to some points on this circle. And then the arcs of the same color as the computers near them are the sets of points which are closer to the corresponding computer than to any other computer. And so each computer is responsible for some arc of this circle, for all the keys that are mapped to this arc. And so what happens when computers come in, because new computers are bought, or when computers are broken? When a computer goes off, when it's broken, its neighbors take its data. So it has 2 neighbors, and its arc is divided into parts, and one part goes to the right neighbor, and another part goes to the left neighbor. And when a new computer is added, it takes data from its neighbor. So it comes between some 2 already existing computers, and it takes a part of the arc of one of them and a part of the arc of another one, and he gets its arc. So let's look at an example. For example, the yellow computer breaks and it goes away, and then the green and the blue computer will take its arc and divide it between themselves. So that's what happens. Another problem which still needs to be solved is that when some computer breaks, we need to copy or relocate the data. And how will a computer know where to send the data that it stores? Well, we need another rule for that. We cannot store the addresses of all the other computers on each of the computers, because that is inconvenient. We will have to constantly update that information. But each node, each computer will be so-called acquainted with a few neighbors. So it will store the network addresses of some of its neighbors. And the rule is that for any key, each node will either store this key itself, or it will be acquainted, it will know some other computer which is closer to this key in terms of the distance on the circle. And that way, if a request comes to some node, any node in the network, about some key, it either can find this key inside its own storage, or it will redirect the request to another node which is closer to this key. And then that node will either store the key or redirect the request to the next node which is even closer to that key. And in finite number of iterations, the request will come to the node which actually stores the key. So that's the idea. And in practice, what we can do is we can put the computers, the nodes on the circle, and then each node will know its immediate neighbors, its neighbors of neighbors, and then its neighbors on distance of 4, and distance of 8, and distance of 16, and for all powers of 2, it will know neighbors to the right and to the left at distance this power of 2. Of course, less than n over half. And it's easier to see on the picture again. So suppose we have many nodes, and then the upper node will have links to its right and left neighbor, to its right and left neighbor on distance of 2, and to its right and left neighbor at the distance of 4, and so on. So each node will contain logarithmic number of links to other nodes, which is much better than storing all the other nodes. And if we need to come to some key from some node that doesn't contain it, we'll first jump in the direction where the distance to the key decreases, and we'll jump as much as we can. If the computer at distance 8 is closer than our computer to the key, we will jump at least by 8. If computer with distance 16 is closer, we will jump at least 16. If computer with distance 32 is farther, then we will jump just by 16. In this way, we will always jump by at least a half of the distance which divides us from the computer that stores the key itself. And so in a logarithmic number of steps, we will actually come from the current computer to the computer that actually stores our key. And this network of nodes which know some neighbors and they know some of their neighbors is called overlay network. So in conclusion, distributed hash tables is a way to store big data on many computers and access it fast as if it was on one computer. Consistent hashing is one way to determine which computer actually owns the data, which computer stores this particular object. And to do that, consistent hashing uses mapping of keys and computer IDs on a circle. And each computer stores a range of keys on an arc, which is closest to this computer in terms of distance along the circle. And also, overlay network is used to route the data to and from the right computer. So when a computer is broken, first its data needs to be copied to some other computers, and its neighbors take its data. So computer disappears and its arc disappears, but it is actually divided between two neighbor computers, and each of those arcs increases a bit, and they cover the whole data. And then we proceed. If a new computer appears, it takes some data from its right neighbor, some data from its left neighbor, and assembles an arc for itself. And I hope that after this lecture you understand how important are data structures we study in this course to the modern technological industry, distributed systems and big data.